All right, let's do a deep dive into two concepts that are just absolutely critical for any good database: indexes and constraints. We're going to break down what they are, what they do, and why you really need to get a handle on both of them.
So here's the big question, right? It's the one every single developer runs into. You're trying to perform this balancing act. You need your app to be super, super fast, but at the same time, the data inside it has to be rock solid and reliable. So how on earth do you do both? Well, that's where our two main players for today come in. First things first, let's talk about speed, performance. Because let's be real, if your database is slow, your users are going to notice, and they are not going to be happy. And the number one tool in our toolbox to fix that is the index. So, what even is an index? Honestly, the best way to think about it is right here on the screen. It's just like the index at the back of a big, chunky textbook. Instead of flipping through every single page trying to find a topic, you just go to the index, look up the keyword, and it tells you the exact page to jump to. A database index does precisely the same thing for your data. It's a shortcut. And this right here shows you the difference in a really stark way. Without an index, if you ask your database to find a user, it literally has to read every single row, one by one. It's called a full table scan, and it is painfully slow, especially as your table gets bigger. But with an index, the database uses that shortcut to jump straight to the data it needs. The speed difference isn't just small, it's night and day. So where do you put these things? Well, the rule of thumb is simple. Put them on the columns you search by all the time. Think about your users table. You're always looking people up by their ID, their email, maybe their name. Those are perfect candidates for an index. Oh, and foreign keys, the columns that link your tables together, those are also prime candidates. But you can't just go crazy and put an index on everything. They're not always the answer. I mean, if your table is tiny, a full scan is already lightning fast, so an index is just extra weight you don't need. And here's the big one. You do not want to add too many indexes to a single table. And why is that? Well, that brings us to the big trade-off. Okay, this is super important to understand. While indexes make reading data, your select queries, incredibly fast, they add a little bit of overhead every time you write data. So every time you insert a new row or update one or delete something, the database has to do extra work to update the index too. If you have too many indexes, all those write operations can start to feel, well, sluggish. All right, we've talked about making things fast. Now let's switch gears to our second pillar, keeping our data trustworthy and clean. And this is where constraints step into the spotlight. You know, if an index is your database's performance tuner, a constraint is its security guard. Its one and only job is to enforce the rules. It basically stands at the front door of your table and makes absolutely sure that no garbage data, no incorrect, invalid, or just plain weird information is ever allowed in. Now, the most important security guard of them all is the primary key. This constraint does two really important things. It makes sure every single row has its own unique ID, so you can always tell them apart, and it guarantees that ID can never ever be empty. Seriously, every table should have one. And here's where our two worlds collide. When you create a primary key, the database almost always automatically creates an index on that column for you to make finding those unique rows super fast. Next up is the foreign key. This is the thing that puts the relational in relational databases. It creates a solid link between two tables and makes sure that link is always valid. For example, it prevents you from creating an order for a customer that doesn't even exist. A foreign key stops that from happening, so you never have orphan data just floating around your system. The unique constraint is, well, pretty much what it sounds like. It makes sure every value in a column is unique. The classic example is a user's email address. You slap a unique constraint on that column, and you can guarantee that no two users can ever sign up with the same email. And guess what? Just like a primary key, this constraint usually creates an index for you automatically to make checking for duplicates really, really fast. A check constraint is cool because it lets you define your own custom rules. For instance, if you're building a website that's only for adults, you can add a check constraint to make sure the value in the age column is always greater than or equal to 18. If someone tries to enter 17, the database will just reject it. Simple as that. And finally, we've got a couple of simple but really useful ones. Not null is exactly what it says. It just stops a column from ever being left empty. And default is its helpful sidekick. It'll automatically pop in a value if you don't provide one, like setting a new user's status to active by default. Super handy. Okay, so we've got indexes for speed and constraints for safety. Let's put them right next to each other and make the difference totally crystal clear. And this table just nails the core difference. Look at the purpose. For an index, it's all about speed. For a constraint, it's all about data safety. One affects performance, the other affects data validity. An index helps you find a user faster. A constraint prevents you from creating two users with the same email in the first place. They have completely different jobs.
So what are the big mistakes people make? On the index side, it's definitely adding too many and slowing down your writes. And on the constraint side, it's not using them at all. And that is just an open invitation for garbage data to flood your system and cause absolute chaos later on.
So this brings us all the way back to that first question. How do you build a database that's both fast and trustworthy? How do the pros do it? The answer is you don't choose. It's not indexes or constraints. It's indexes and constraints. A professional, robust database uses both of these tools for what they were made to do. In fact, we've already seen how they're often linked. You use indexes strategically to tune your performance, and you use constraints religiously to make sure your data is always correct.
Let's just boil it down one last time. Index means faster queries. Constraint means safe and correct data. It's speed and safety working hand in hand. That right there is the sign of a really well-designed database. So I'll leave you with this final thought. As you start your next project, or maybe even look at one you're working on right now, ask yourself, which side of this coin needs more of your attention? Is it the speed of your queries or the safety of your data? Because knowing the difference and knowing when to use each tool is the first step to building something truly great.